Here we go. Here we go. Here we go. Here we go. Here we go.
Hey everyone, how's it going? We are back with our second and final demo of the day here on AWS What's Next, episode 10. So joining us for this very special session is Anabell St Vincent, Principal Solutions Architect over on the AWS Robotics and Autonomous Services team. And she's here to talk to us a little bit about Amazon RoboMaker WorldForge. This is something that launched this week. I'm very excited about it. I got to read a little bit in the launch blog post, but I figured we could toss it over to you. But before we get started, Anabell, thank you for joining us. I know you're probably quite busy, especially with a recent launch, so we always appreciate service team folks coming out and helping us with this.
Yeah, it's been a busy week, but thanks for having me on. Hi, everyone.
Welcome to the show, Anabell.
Thank you. So yeah, it's been a really interesting week. We just launched AWS RoboMaker WorldForge, which is a new capability that makes robotics testing in simulation and training and synthetic data generation much easier. So WorldForge makes it faster, simpler, and much less expensive to create multitude of 3D virtual worlds to simulate your robots in. I was
gonna say, you had me at less expensive. Anytime you launch something that says, hey, you do this already and you can do it for less money, I'm sold. I'm on board, right? But you said 3D worlds, creating those in an easier fashion.
Absolutely.
Yeah, why don't we talk a little bit about that? I mean, the full title is RoboMaker WorldForge, right? So folks may not be familiar with RoboMaker, but what kind of 3D worlds are we talking about here?
So we're talking for this initial launch, it's focused around inside houses. So these worlds are made up of rooms and apartments and some bigger houses, which I'll show you a bit later during the demo session.
Yeah, my world would be pretty easy to simulate. As you can see around me, I just live in the lobby of an Amazon office and just do all of my streaming from here. So probably easy to simulate, but maybe we'll get a glimpse of what that looks like later. So gonna do some more sort of base building here. So we're talking about WorldForge, which simulate 3D worlds more effectively. This is a feature of RoboMaker broadly. So can we talk a little bit about how sort of these two things fit together? I mean, I'd imagine that RoboMaker is the larger umbrella service, and then WorldForge sort of fits into that a little bit.
Absolutely.
Yeah.
So AWS RoboMaker was actually launched at reInvent in 2018. So that was it was a brand new service then. So what it provides is a complete cloud solution for robot developers to simulate, test, and securely deploy their robot applications at scale. It enables the customers to test their robot apps more easily in simulation. And they can do better testing, they can do more testing, and in order to hit any of the edge cases that you might have when you're going through your regression testing as you're iterating through your development life cycle. So what WorldForge has done is brought this capability to create these 3D worlds so you can simulate your robot in hundreds of worlds concurrently in simulation, so then you can have better quality robot applications that you produce. And as a result of that, you can generate synthetic data that you can use to improve your code, or you could use it to do analysis, but also it's good for regression testing and also reinforcement learning. So
this is super exciting. I mean, this is essentially like the RoboMaker broadly. It sounds like the virtualization of these simulations, and you know, you mentioned cost, you mentioned speed, the ability to test in parallel, let's say, regression testing, all of this. You know, when we talk about robotics, I think everyone probably has a different sort of idea that comes to their mind, and maybe I'll throw the one that comes to mind for me. You know, if I'm thinking about robots and a use case where they're used, I'm thinking almost like autonomous house cleaning, right? Like a Roomba.
Good example.
Yeah, I think they're an AWS customer. Am I mistaken, or?
They are. No, they are a customer. And as part of this, we announced the WorldForge as part of our first ever Cloud Robotics Summit, and we had Mark Cedron, he's the manager of simulation team at iRobot. He also presented on Wednesday, and he mentioned that how they've been using RoboMaker and has improved their testing cycles that they've been doing, and also how they're looking forward to using WorldForge to be able to have a more diverse groups of worlds to be able to test their applications in as well. Just to
So,
give you an indicator, they test, they simulate, run simulations, 60 simulations per build, and they have lots of builds and they have lots of different robots. So they actually run 5,000 simulations a day. So he said that in his presentation. It's on YouTube. You can go and see it later. But yeah, so this has improved their the quality of the robots that they're building, of how they operate, and also like the speed of deployments of their applications.
yeah, let me just kind of play that back to you, make sure I understand what the customer benefit here is, right? So you're saying that they're running 5,000 simulations a day, and these are all in virtual environments.
Correct.
And what this is helping them do is to catch defects before, let's say, a new behavior, a new navigation system is deployed as a software update to their robot fleet, right?
Absolutely.
Because a lot of us have Roombas, a lot of us are iRobot customers, and they're constantly improving the capabilities and the intelligence of their robots. Now, part of what they can do is certainly take the telemetry from their fleet in real time, or I don't know how they collect their data exactly, but also part of it, I think what you're describing, correct me if I'm wrong, is that we have this full suite of simulation that we can use to kind of get them partway there and not rely entirely on real world data. Is that a fair assessment?
Totally.
I was gonna say, like, the journey from on-premises to cloud is monumental for a lot of customers for a lot of different reasons, but I'm almost trying to imagine what mass scaled out simulation across many different environments looks like. And I'm just imagining the scenario in which there's like this massive building in the middle of like the desert or something, and then they just go, all right, yeah, I've got all of my robots, I'm going to test them in every one of the rooms in this building that's engineered to be slightly different. And if that sounds absurd, it's because it is, right? Like the sort of world before simulation was largely that you just operated without all of the data. Otherwise you would never have the full suite of data to ever go out and say, yep, we've checked on everything. But that's where simulation comes in. And I think that's where WorldForge is going to shine here today, right?
Totally. I mean, that's where RoboMaker has also improved that whole experience for our customers, because traditionally you would have had to build your application, then either copy it to a USB drive or connect to your robot to deploy the app, and then run some tests. So you have to also create the environment around that robot to test it. But with simulation, you can do that in simulation, get your data, and do it concurrently. So regression testing is definitely a huge factor here, that you can keep iterating over your code, make sure the new code you'd released didn't break it, that all of a sudden it stopped recognizing the couch and it's going to smash into it. Those things are definitely, RoboMaker as a whole has helped that. And now with WorldForge, you can do that in 3D worlds that are simulated for you at a large scale. Because traditionally, to be able to even get into simulation, you have to create these worlds, and these need specialized skills. Like you need people that know how to create 3D worlds. It's a specialized skill. You need people that understand different simulation engines to be able to effectively create these. So WorldForge simplifies that you don't need those skill sets, and you can just by just 3 clicks, you can create a 3D world and then run your application in simulation.
Yeah, definitely. Now, every time I partake in a conversation about robotics, it's not long before somebody brings up the robot operating system, also known as ROS. How does that fit in here?
Yeah, so ROS, or Robot Operating System, it's an open source framework. It's the oldest and widely used operating system per se, but again, it's a framework that sits on top of Linux. That's what people were seeing huge adoption of it globally within the robotics companies. And recently, last month actually, so ROS2 Foxy Fitzroy distribution was launched, and that launch was specifically focused on making sure the distribution is production ready. It comes with security and reliability, which are the key factors when you want to deploy production ready applications. And AWS has also contributed to that distribution as well. There's many distributions, but this is the most recent and most reliable and future-looking version of ROS. In addition to that, AWS has also developed cloud extensions, ROS cloud extensions. And what that does, it makes it easier to extend your robot applications to use either AWS services. For example, like Polly for speech generation, Lex for speech recognition, or Kinesis for video streams, right? And we've got CloudWatch extensions as well, where you can collect your logs from your robot application in simulation and also from physical robots, and as well as the metrics. So they're all, you can see all your logs in one dashboard collected together, and you can, again, run analysis on them. And the most recent extension that we released is an S3 uploader, which is what it actually does, it actually records ROS bags. ROS bags is a term, I guess, within ROS that you collect data and sensor data, for example, and you can push that directly to S3. So these extensions help robot application developers to extend their application and leverage AWS services to have a more comprehensive and fully functional robot applications.
Yeah, I mean, it sounds very exciting. I mean, the promise of standardizing an interface or a framework around these common, let's say, input and output aspects of robots, like, there's a microphone, and then the ROS framework enables sort of the ingestion of that audio stream. And then, hey, look, we can use something like Transcribe as the cloud module on AWS to then, or the ROS cloud module that enables us to send that signal out to Transcribe. And you can just more quickly power your robot applications and your robots themselves with these other services that AWS is building for, let's say, traditional workloads. I don't know if robots would not technically be a traditional workload, but you get what I'm saying.
Absolutely.
So really cool. You mentioned before sort of this paradigm of building, testing, deploying, and simulation, which is really the star of the show today. But to give people a flavor beyond my ridiculous scenario of buying out a hotel in the middle of nowhere to simulate all my robots on, what does build, test, deploy really mean in robotic development?
Yeah, like I mentioned before, like previously you had to you build your application so that you generally you'd build it on your own laptop. So you build the app, then you have to package it in a format that your robot will understand, copy that to the robot, then run your app, and again, create the environment around that and validate what you just tested. And if you've got a small bug, then you have to redo all of that again, right? So I guess that's more the traditional way of developing robot applications. But as with simulation, that's where the power of simulation helps that process. And being able to do, I guess, simulation on its own, you can do that, absolutely. You can simulate, Gazebo is one of the simulators that is open source, and you can run that on your own machine. But, some worlds or some applications need a lot more compute capacity. So then maybe your machine doesn't have the capacity. Or you want to run multiple simulations, concurrent simulations at the same time. Again, you can't run it, or you need the infrastructure to do that. So that's where RoboMaker comes in, where you can, it's a managed service, undifferentiated heavy lifting is done for you. I just wanted to throw that in from the previous session. So it's a managed service, so we scale with your simulation. You can run concurrent simulations at the same time. And that's the bringing the power of cloud to robotics. And it's a game changer when it comes to the robotics industry, for sure.
I love it. I don't have to say anything today. The guests do all the work for me.
If you don't. However, I will tell you that in the fullness of time, you will slip up.
Fullness of time. All right, we're just throwing in all the slogans today. I love it.
And of course, And of course, it's pay as you go pricing, right? It's true though, but so simulation, you pay for the simulation that you run, and you can specify how much CPU, how much memory you want to allocate to it. And if it fails, you see it failed, you can just stop it and stop paying for it. So
Yeah, on the topic of simulation, we've talked about how this enables you to, or customers that work with robotics and want to be able to perform these simulations. There's a let's say orders of magnitude cost reduction and operational or time reduction. But something else that starts to come to mind for me is that, like, what if the location that this application would be deployed in does not have an easy way to test in, right? So let's say we're
exactly.
like, I don't know, like, let's say I want to
Underwater.
train a drone. Underwater is a good one. I was saying, like, if I'm gonna train like a drone and I fly it over a volcano to test it and it just falls in, and then oops, that was an expensive mistake, right?
Absolutely.
So is this something that we see customers looking to something like RoboMaker and even WorldForge to help them with?
Absolutely. I mean, that's one of the reasons. So I guess from an expensive part, testing physical robots is expensive. So um, so if you're, like you said, if you crash your robot, or if it falls in a pond, or there's a lot of different factors. So it crashes into a tree, um, so there's a lot of reasons why this can be expensive. And like even the robot arms, like they're very expensive devices, and you don't want to be testing on those so frequently. So that's where definitely simulation helps that. And but you still have to do some physical testing. It's not going to be without saying, because there is different fidelities so available within different simulation tools. So lower fidelity is medium. If you need like really precision, for example, like vibrations that you need to test against, there's some things that you need to do on physical robots. It's not going to happen. You can't do everything in simulation, but you can get majority of your bugs out before you actually deploy it to the robot.
We can simulate the phenomena, we can model and quantify, right? That's we can only test what we can simulate and what we
Yeah.
can understand, but we know that the real world always data
Yeah.
is dirty in the real world. That's
Yeah.
kind of the saying in
Absolutely.
machine learning, at least. So
And I guess we've started with WorldForge being a like inside houses, indoor space, but this is the start, right? So the opportunities out there. What do robotics companies want to simulate? What worlds do they need? Is it hospitals? Do you need different types of layouts of hospitals to validate your robot that's going through maybe cleaning the hospitals, um, or sterilizing the hospitals? Planes, do we want to sterilize planes, and what do the formats of those look like? So this is sort of starting that opportunity, to see what customers want. And as you guys know, 90% of our capabilities and services are based on what customers need. So this is the start, and what the customers ask for, that's what we're going to focus on and build for them, so we can make the robotics companies effort easier to be able to build and deploy great robots out there.
awesome. And I could pretend like this is a question I don't already know the answers to, but when we're talking about making these environments indoors, especially with WorldForge and being able to create these to power these simulations, essentially, WorldForge was released as generally available this week, or was rolled out to regions that RoboMaker is available in this week. But it sounds like something that's very visual, and anytime there is something visually oriented like that, I know I learn better by just seeing it in action. So
Okay.
would you mind showing everyone?
Absolutely, happy to. All right, let's get. Okay. All right. So this is the RoboMaker. Okay. All right. This is the RoboMaker console. So I'm just want to show you. I'm in the Oregon region just for this first part of the demo. So this is, you can see here, WorldForge new. This is what we just launched. So this is the new part of our console. So if you go to World Templates, you can go and click on template. You can, here you can see the different types. So this is a sample of a world, like a house, and there's connections that happen in between the rooms, and there's different materials and furniture. So I guess that's another hard part, right? When you're doing this in simulation, you have to generate all these furniture and materials for simulation. And then there's a concept of where your robot starts. So there is a default location for these worlds that are set, where when you start your simulation, your robot will start in that location. So that's what that green button is. But let's just quickly just show you what there is. But how quickly can we build a world? So we've got some templates. So this is, first one's just a bedroom. And then we have a living dining room template as well. We have a 1-bedroom apartment. So you can see there, and a small house. So what I'm going to do is quickly, I'm going to say start. Let's try a living dining room. I'm going to say generate world. And floor plans, I'm going to choose there's different types of floor plans you can use. Again, these are randomized. So, and 2 different types of interior variations. I'm going to say generate. So there, my worlds are being generated. We're going to go through, create another one. This time, let's choose the 1-bedroom apartment. Let's say start. I'm not making any changes here. I just want to show you how quickly these things come up. I'm going to do 2 here, 2 here. Click generate. Right. And then we'll do 1 more of the house.
And while you're creating these, I guess to reiterate for everyone who may be watching, the idea of being able to have WorldForge automatically do the varied environments through just simple variables here, right? You here, like in machine learning, this would be like hyperparameters and a search across the hyperparameters, but here it's just, hey, you want X number of volatility or of variance in these rooms, and otherwise you'd have to do that manually, but randomness can just be boiled down to an integer here, and WorldForge and RoboMaker just take care of the rest, it seems.
Absolutely. So there you go. So we're just, the ones were just created. So you can see these are the 2-room variations. So you can see they were slightly different. The furnitures are a bit different in each one. So that's what you want that randomness, right? To be able to test. And then here is different variations. So I created some more for refresh it.
And Anabell, to be clear, because I haven't used this before, these are more than just pictures of the room, right? This is not just dynamically generated art. This is a full world, 3D world with all of the properties that someone could deploy a robotic application to in RoboMaker and perform the simulation directly in this.
Correct. I'm going to show you that in a moment, right?
Oh, okay. So, I'm jumping the gun.
We're just,
sorry.
That's right. But yeah, this is like, this is what we just created, right? Just by 2 clicks, right? We just created these worlds here. So now I'm going to switch regions just for the sake of this. What I'm going to do is just give you a bit more detail around these worlds. So we'll see them a bit better in this part. So I'm going to create a new world. I'm going to use the 1-bedroom apartment. And here, so this is where I want to sort of give you a bit more detail what it has. So you have a bedroom. It's got a living room, a bathroom, and a kitchen, right? So then, and you can customize the size of the rooms, the interiors, what the floorings look like, what the walls look like, and what furniture. Like you can see here, the furniture is dense furniture room type. So these things are important, right? Especially like flooring. For if it's carpet, does the robot get stuck in the carpet, or is it slipping on the tiles? Those things you want to test for. Hence why you need the different types of materials in your worlds. So let's just say we've got this 1-bedroom apartment, but I'm going to need another bedroom because I need some space to work from home.
Don't we all?
So, so I'm going to add, bedroom 2, and I'm gonna say it's another of type bedroom. I'm gonna leave the areas as default. I'm gonna save it, but then I want to sort of make maybe some changes around the interiors of it. So this is the room I just created. I want to override the connection. So connection is like how the rooms are connected to each other, right? So I'm going to say add a connection, and I want to say that I want it with a doorway, and my bedroom is going to be connected to the living room, and save that.
So this is quite intricate. You know, I'm imagining if I were trying to do this outside of WorldForge, this would be the task of a designer, a 3D modeler, to actually construct that in that way, unless they had built some sort of internal tool to even do that. But that sounds very difficult.
Absolutely. So that's definitely one of the reasons. And then the other part is like all this, I'm just going to create it. And because it has a type of a bedroom, it's going to put some bedroom furniture in there as well, right? So custom flooring, so you can choose different flooring types as well. So there's like, you can see some, like this is carpet, that's what you're seeing. So floorboards, you can see different types of samples of the floorboards. Let's just say we're going to use tiles for this room, and we're going to save it. So these are some of the changes I guess you can make when you're creating a world, and these are all customizable. And once you create it, so this creates a template, right? It's not the world. And from this, you can create different variations of it. So that's where I guess it becomes powerful. So let's go ahead and create this. Let's just create 2 of each, 2 variations and 2 floor plans. And while these worlds are being created, what I want to show you here is quickly that, so you know, if you wanted to try this yourself. So if you go to resources and just deploy the Hello World, like literally click on that and create launch simulation job, that's going to give you a sample application. So with that sample application, I'm going to use that to drop my robot in this world that we just created. So
for example, that sample application would be like the equivalent of whatever application I had built that would perform the behavior my robot would want, and that is what like the application is what I'm technically testing inside of the WorldForge's world.
Correct. So there's 2 concepts. There's the robot application and there's the simulation application. So in this scenario, we're going to use the simulation application. Yeah. So if you look at, because I've deployed it, so if you look at simulation application, this is what you see. And that, again, like, since you can just deploy it from the console, but it's also open source. So under AWS Robotics, this is the open source application. So if you want to look at the code details of it, you can easily get access to it from there. So then if we look at our world, they're still generating, when it's still running, so you can see the running job, and it's creating 4 different worlds.
So the reason why it's 4 would be because we had 2 different variables, and we chose 2 versions of each. So it would be the what is it, the word when you multiply 2 things, the product of the 2. That would be the resulting number of worlds.
Correct. Cool. There you go. And they're just created. So we just added, remember, it was a 1-bedroom apartment. We added a bedroom, and we said we want 2 different variations and 2 different floor plans. So you can see the floor plan slightly different from the top and the bottom ones. You can see them slightly differently. And you can see the green is, again, where the robot gets dropped when you start that.
Waiting for the first apartment building to be built entirely by rooms generated in WorldForge. That'll be a fun one.
So now let's go ahead and create a sim job, right? Let's create a simulation job using one of these worlds that we just created. So in here, again, this is using the role that gets created as part of the Hello World deployment. Here we're going to choose melodic, which is one of the ROS distributions. And we're going to go next. And we're not going to use a robot application per se, because the default robot application in this just goes in circles. I want to control it just to show you the view from the robot. And here we're going to use the existing sim application, which is that hello world again. And so launch file is what you see here. That's the launch file. So there's a WorldForge launch file available as part of this sample application. And the package is just make sure. Hello world simulation, great. And here we'll say import the world from WorldForge. So then you can go and browse your worlds, and these are the 4 worlds we just created. So let's pick one and choose the world. Next. Create the job. So this is creating a simulation job that we can then go in and have a look at, interact with it in Gazebo. I'll show you that in a minute. So while that job is being created, what I want to show is that these jobs, these worlds that you've created, what you can also do is, so you can choose the job and you can export it. When you export a job, it puts it in an S3 bucket. So you can choose your S3 bucket where you want it. And I need IAM role to do that and create. So the exporting, a lot of people use their own laptops for development, like I was mentioning. So you might run Gazebo, you're developing, you're doing unit testing on your laptop. So this world you've just created, you want to do some unit testing on your own machine. So this exporting it means that you can then get a copy of this world and use it in your Gazebo running on your own machine as well. So
that's actually a good point that you brought up about folks doing maybe unit testing or trying to do development on their own machine. You know, anything graphical, I imagine, makes better use of your generation of these worlds. Maybe it would entail better performance with a GPU, let's say, but that often involves a more expensive device, right? So
correct.
I'm seeing here a world in which WorldForge, no pun intended, is enabling folks to now develop something that they otherwise would have been locked out of previously if they didn't want to invest or weren't able to invest in a device of that size, and with all the benefits of all of the on-demand nature of managed AWS services.
Absolutely, yeah. So you can see that's the job, that's the world we just created, and it's been exported as a zip file. So you can download that locally on your machine and run it against your code that you're developing locally and do your unit tests, etc. So by now, we should have, now we've got our simulation. So this is the simulation job we just created with our brand new world. So let's go and look at that. So as part of RoboMaker, what we provide is managed Gazebo. So this is Gazebo client, RViz and RQ2. These are some of the tools that robot developers use as part of their development cycle. So you've created your simulation and you can connect to it.
So similar to how I would, spin up a fresh instance and SSH into it, I can go directly into the simulation as it's happening.
Yes. So this is simulation as it's happening. So, and
I feel like this is this sounds quite familiar. I ended up wearing my Deep Racer shirt today. I don't know if the sleeve can show it, but with Deep Racer through RoboMaker, I believe you can also sort of take I'd say bird's eye view, but it is like car's eye view from the track and see what it sees inside of a simulation world. Yeah. So I'd imagine it would probably look something similar to this, right?
It would, because Deep Racer actually uses RoboMaker. So yeah.
It's all coming together. I'm like 5 for 5 today. I just can't miss. Yeah. Wonderful.
So this is the world we just created, and right in the middle there where you see the dot is where the robot is. That was the placement, the green cylinder that we saw. So that's where it got dropped in as part of this.
Hold on,
And-
I think there's a screen sharing issue. What we still see is your AWS console.
Oh, really?
It may have come up in another
Sorry.
window, maybe.
Yes.
If you drag the tab into this window, it should probably work as is. I don't know if that's possible.
Can I
Oh.
share all of it?
Oh, I see
Okay.
that third. Yeah, there we go. Awesome.
Okay. Yeah. So that's what we're seeing. So this is actually, so that's the world we just created. And the robot is dropped in the middle there. And then I guess I need to then show you the other part of it. So I'm going to open another tab, but I need to make sure to share that.
I think as you popped that one out, I don't know if the other browser. Oh, actually, no, we see that. Yeah.
Well,
It looks like it's loading right now, right?
yeah, I want to see if I can just share the whole thing that way. Because I need them side by side.
Yeah, desktop or desktop capture probably will work well for that. But I was going to say, so this is quite interesting because otherwise to explore these 3D worlds in this way, it looks like I would need to download maybe Gazebo or whatever this 3D modeling software is and open up the world inside of there to be able to then do that. But this is all directly in the browser through the console, right? I don't have to install any other software, right?
Correct. That's it. Absolutely right. Yeah. So this is...
It's probably
So
looking straight into a couch or something. Is
Yeah.
that what we're...
So yeah. So can you see both of them now, or you're just seeing? the
No, I
one?
can only see the one that shows the red texture. It looks like Sim 48LFFKJ.
Yeah.
Yeah. I think if you go to screen share and then do desktop share instead of window capture, it may improve that. But if we're trying to show both at the same time,
Let me
yeah.
try it. To
Yeah,
do-
no worries.
I don't- Nope,
We
not happening.
that's okay.
All right. So then I guess the other part of it is to be able to, you can steer the robot as well. So, but I guess the key. So
Oh,
now
there
you
we
can
go.
see.
So those were
See?
walls, and it was looking
Yeah.
right at a wall before.
Yeah. So it's just going in circles at the moment and it's looking at all the furniture around it. And
And we want to move closer to that. Let's say we want to move closer to that corner over there by some of that furniture. Is that like throttle,
Yeah.
let's say, or moment
Okay.
of velocity in either the forward or back direction? I see meters per second. Yeah, it's
There you
bringing me
go.
back.
it's moving closer to it. Yeah.
Cool.
Now, Annabelle, can
Yeah.
we destroy this furniture with the robot?
Yeah, you can smash. You want me to smash into it? Is that what you're saying?
Yes, let's do it.
Full speed, just full
And-
gas.
There you go.
All right.
We're right. We're stuck behind it.
All right, 5 points.
I'm imagining a world where we have, we have Deep Racer. I know a lot of folks always enjoyed the show. What was it, BattleBots? Let's say. I'm waiting for a day where we have a BattleBots simulated competition, and seems like this would be maybe the precursor to making something like that possible. So I'll go out to the lab and see what trees I can shake and make that possible. But that sounds
I'm
exciting to
telling
me.
you, some
Good
sort of
deal.
deal between AWS and BattleBots needs to happen.
Yeah. But this is, I guess, this is what we just created, and the robot is placed in it, and it can, I guess, move around. So this is where your application would run. So you would write an application to do, for example, object avoidance, right? Or to navigate through all of the floor plan right? So those are the things that you would build in your application. And then when you run them in simulation, then you're able to see, to test, generate synthetic data, or validate your application. So make sure it doesn't, run into a run into a cabinet or a wall or etc. Again, because they can be expensive. So
this is super interesting. I mean, I'm a huge gamer. I know Rob is as well, and in the video game space, a very tangible problem for players and for game studios is the ability to, let's say, make environments in a way where it's time efficient, where they've made a bunch of assets, but then they string them all together very manually. How do we not repeat that world, let's say? So like, how do we randomly generate sort of parts of the game that our players will go through? And this has been a problem and a challenge for video game producers for a very long time. I know we're very pointed here with the simulation space, but just trying to wrap my head around how far all of this technology has come to generate a randomized 3D worlds. It's fascinating.
Absolutely. I mean, so it's like I say, I studied robotics in the university, but that feels like ancient history these days. It's just what the things that how companies have evolved, how robotics has evolved since then. It's just amazing. I want to quickly show you the worlds we just created in the other region earlier. So these are all the worlds here when we went, the variations, but so you can see like there's 3 pages worth. So imagine we just did this in the space of this time. We created all these worlds, and the space is, as I was showing you, the other parts of it. And there's 3 pages of them, right? So, and you can create hundreds of these just by running a single API call, or a few clicks away. Customize them, put some variations in them, and then create and run hundreds of simulations in parallel.
That's awesome.
It's also very interesting to me, the ability to also, I know there were a few checkboxes or parameters we could randomize across, but even starting location is something that sounds simple but has immense value to randomize, right? Like, say for example, like the old DVD wallpaper, or the old like screensaver where the like little thing just like bounces off all the corners and such, right? Like if you start with the exact same location every single time for an app, for a given app that you're trying to test, you may never encounter a scenario where, let's say, the robot would end up in the corner, and then you've never tested that case because you started with the same seed in every single one of your simulations. But by having different starting locations, you're essentially randomizing that seed. You are basically ensuring that your simulations are going to be more all-encompassing than otherwise. So that's really cool. It's a subtle thing, but it has a big impact in like the behavior of robots, because that could prevent, let's say, a build going out where everyone then reports like, oh yeah, this exact same weird behavior, like when it's caught between 2 chair legs, it just doesn't know what to do, right? Like this randomization helps to curtail that early on in the build and the testing process. For
sure. Like the robot could say, your Roomba could be under the table somewhere. It might be stuck under a chair or a couch, right? So how do you test for that, right? So yeah, definitely it will help in those scenarios for sure. So I guess, that's all I wanted to show in this, is just how easy it is to create worlds and then be able to, I guess, export them and be able to run your unit testing on your own machines directly on the world you just created.
Well done.
Yeah,
well done.
I know you said that's all you wanted to show, but the ability to spin up an innumerable number of virtual worlds with and you can string them together in all of these ways based on the pre-built templates with all of this randomization. That is nothing to scoff at. That is nothing to minimize. That is an immense problem and challenge that anyone working with robotics or trying to simulate is definitely jumping out of their seats to try and get their hands on right now. So
absolutely, yeah. But I guess we've made, I'm saying all, but I'm saying how easy we've made it, how easy WorldForge has made it for the QA engineers or the robotic application developers to do that. Absolutely.
Yeah.
Wonderful.
So, you want to leave us with any sort of how do people get started with RoboMaker? What are the resources and call to actions that we can share with the chat?
Yeah, I mean, just like you said, right? Go ahead, just run the Hello World application. Just go and start creating some worlds. Just see how easy it is to do that. And just remember, creating these 3D worlds used to be a lot harder, more expensive, and time consuming. You can do that easier, faster, and cheaper now, for sure.
Wonderful. And there are a few things I would love to see in WorldForge. Like if I could get a giant robot in there, that would be really cool. I could think of a bunch of different things, but if folks have a particular object that they would like to see supported directly in WorldForge, is there a way for them to let you know?
Absolutely. So like I mentioned earlier, like this is the start, right? So we want our customers to tell us what they want, and that's how we build our services. So please contact us, let us know your use cases, and we're more than happy to work on that, for sure.
I just realized how silly the idea of using, of mentioning a giant robot in RoboMaker, which is designed for robots, but you get what I mean, right? If I wanted the Eiffel Tower, let's say, or the Statue of Liberty as a giant model inside, maybe that would sound a little more fitting. But yeah, cool. Well, yeah, we will get that that email address thrown out in chat. So again,
awesome.
Here on the What's Next show, we love being able to surface the service teams that build these things, connect them with the community. It goes both ways, right? Sure. So wonderful. Well, I'm sure we have some links. We could also, we have those in chat. Cool. Well, this was building 3D worlds in with WorldForge in minutes. Very exciting stuff. Man, I'm trying to think. Is there anything else? I can't think of much. I mean, again, it's all in the console, right? You don't have to leave.
All in the console.
No other software, and.
Yeah, I mean, the thing is, like, if you want to build your own robot application, then you can either use the development environment in RoboMaker or use your own laptop to build your own robot application, and then drop that in, use that as the app in your world that you create. Yeah.
Wonderful. Well, I think we're approaching on time here for this session, but Anabell, I wanted to say thank you. This was really great. I don't get too much of an opportunity to dive into RoboMaker personally outside of some of the Deep Racer stuff that I do, but this new launch in WorldForge is very, very exciting. I know any of the customers already working with RoboMaker are going to be quite excited about it. So
absolutely.
Yeah, thank you again. Yeah. Awesome demo.
Thank you. Thanks for having me. Thank you.
Thanks, Anabell. It's been a pleasure and a privilege.
Here we go, here we go, here we go, here we go.